Hello everyone. I'm Janki Barod, Assistant Professor of Department of Computer Engineering, Aditya Silverok Institute of Technology. Today I'm going to explain the types of memory allocation and its technique in operating system. Let us see the agenda which we are going to cover during this lecture. We'll see what the types of memory allocation, we'll discuss contiguous and non-contiguous memory techniques, and we'll see single process monitor, contiguous memory allocation, and the other method, that is multiprogramming with fixed partition, right, which is also the technique of contiguous memory allocation. So without wasting time, let us start memory allocation and its type. As you've seen in a figure that through main memory, memory management memory manager will allocate the memory based on two techniques, right? First one is contiguous memory allocation and the second one is non-contiguous memory allocation. If you're doing contiguous memory allocation, there are some techniques, that is single process monitor, multi-programming with fixed partition, multi-programming with dynamic partition, and in non-contiguous you are having two techniques, that is paging and segmentation. In this lecture, we are covering single process monitor and multi-programming with fixed partition. Multi-programming with dynamic partition will be in next lecture. Let us see what is contiguous memory allocation. So, contiguous memory allocation is the simplest and oldest allocation method. It is not used in a modern operating system. Each process occupies a block of contiguous memory location in main memory. Entire process kept together in a contiguous section of memory. When process is brought in a main memory, is searched to find the chunk of a group memory or a group of a memory which is having enough size to hold that process, because if the process is having a more size or required a more size for the execution, right, we need to allocate particular that type of chunk to process. So if contiguous memory space of required size is not available in a main memory, this process is made to wait until contiguous space of required size is available. Process logical address space is not divided into any partition. Physical address space will be contiguous without any gap. Let us see this diagram. Here we have seen that logical address space of process is here and physical address space of process is here. Here it is mentioned that base address to up to maximum size of address. Here also we can see that base address to the maximum size of that physical address, right? Now, here we can say that advantage of contiguous memory allocation is easy to implement and understand, but disadvantage is having poor memory utilization. Why? Because if we have the fixed part, if we have the fixed part of size to allocate the memory to the particular process, it may possible that many process doesn't require much memory, right? So at that time we are wasting our memory, and sometimes it happens that we require more memory than available memory. At that time we need to wait for free memory. Now we'll see non-contiguous memory allocation. Now, this is used for modern operating system. Here, logical address space of process is divided into partition, and for each partition, contiguous chunk of free memory is allocated. Physical address space will not be contiguous. Now, let us see the diagram that here logical address space is there, X, Y, and Z process is there. Now, this is the main memory, right? Here we are not having a continuous memory location, right? If this chunk of memory, this unit of memory is free, or you can say that the size of this memory unit and the requirement of Y process is matched so that Y is assigned to this memory byte, right? So likewise, according to the size and according to the availability, the process will be allocated in a main memory for the execution, right? So we can see that here physical address space will not be continuous now, right? The advantage of non-contiguous memory allocation is having a bit better memory utilization. And disadvantage is it is complex to implement and understand, right? We need to find to allocate a Y, to allocate main memory to Y process, right? We need to check whether any available slot is there, and from the available slots we need to find the exact nearby size of that unit, right? So it is complex for implementation. Contiguous memory allocation. Three different ways for contiguous memory allocation. First one is single process monitor, multiprogramming with fixed partition, and multiprogramming with dynamic partition. It is also been called that static partition and variable partition. We see single process monitor. Single process monitor is the simplest possible memory management scheme. Only one process is allowed. Due to here written that single process monitor, it is for only one process is allowed to run. No more than one process can run simultaneously. Memory is shared between process and operating system. So there is a memory. Let us see that there is a memory. In a main memory, there will be operating system and as well as user program RAM available for running the process. Both will be in a same memory, right? So memory is shared between process and operating system. This method can be used in palm-top computer, embedded system, PC running only in MS-DOS, right? Only one process can run at a time. When user types a command, the operating system copies requested program from disk to memory and execute it. Here you can see that device driver is here, user program is here, and operating system is here, right? What operating system will do? It will copies requested program from a disk to main memory, right? So this is all about single process monitor. When process finishes, the operating system displays a prompt character and wait for new command. Why? Because only one process will run at a time. When operating system loads new program in a main memory, overwriting first one and execute it, right? When another program will be loads, new program will be loads, it will be overwrite to the previous one, and then after it will be executed. Advantage of this memory allocation is simplicity. But the disadvantage is only one process can be executed at time. Now we'll see the second part, that is multiprogramming with fixed partitioning, right? So this method allows multiprogramming with fixed partitioning, right? So it will allow for running simultaneous process, right? But it is having the static partition. This method allows multiple processes to execute simultaneously. Memory is shared among operating system and various simultaneous running process. Multiprogramming increases the CPU utilization. CPU can be kept busy almost all the time by keeping more than one process simultaneously in memory. Memory is divided into fixed partition size that can be equal or unequal of different partitions. So there is not fixed that all partition will be fixed, right? It may be different size of partition. Generally, unequal partitions are used for the better utilization of a memory because some of the process doesn't require more size for the execution, right? Each partition is accommodating exactly one process. Means in each partition, only one process will be there, right? Whenever program need to be loaded in a main memory, a free partition big enough to hold program is found and allocated. What here written that whenever the program need to loaded in a main memory, free big enough partition will be hold for that process to run. If there is no free partition available of required size, right? There are free partition, but it is not the able to acquire that process, right? Which process need to wait? That process need to wait such in a queue. We need to put in a queue because the size that they require won't be available in a partition, right? So here there are two possible way to implement the method with a queue. Multiple input queues and using single input queues. We are having two figures. It is multiple input queue and single input queue, right? Here you can see that this is a main memory and having operating system here. We have a different partitions that are not equal size, right? Unequal partitions are there. Now, what we have written here that if there is no pre-partition available of required size, which process need to wait, that process need to wait and it will be put in a queue, right? So it may possible that partition 1 for partition 4 and for partition 2, the size of this square, this processes, right? Requirement of this process can be fulfilled by partition 1. Requirement of this process can be fulfilled by this partition, right? Any requirement, these two process, right, is available at partition 4, right? So at that time, it may possible due to it is multi-programming, there are many process which is running simultaneously, right? We need to put in a queue for partition 1 for requirement of this memory size, right? This partition size. There are some queues, right? So here multiple input queue is there. In figure B, we can see that single input queue is there, right? In this process, what is happening? That when as and when the process will come according to available partition and available partition size, the process will be allocated to that particular portion, particular partition. Okay, now we'll see that using multiple input queue, how it works. For each partition, separate queue is maintained. Each partition, separate queue will be maintained. Whenever any process comes, it is put in a queue for smallest partition large enough to hold it, right? What we are doing here, whenever process comes, it will find that the smallest partition will find the smallest partition which is large for these processes. Okay, so that we are able to utilize all the partition and we can manage the available memory. Now, when partition become free, a process from that front end of queue is allocated that partition. As soon as this partition will get free, the first process will be enter in a partition 1. Okay. So disadvantage of this using multiple input queues. If queue for a large partition is empty, queue for a large partition is empty, but for small partition is full. Small process need to wait to get memory. Here is the example that we are having 3 process in a queue for partition 1. But here for partition 3, because it is a large partition, right? We are not having any queue and it is still free memory and we can't utilize it, right? This process won't go and won't utilize partition 3. So here I'm reading again that if queue for a large partition is empty, this is empty, but for small partition it is full. For small partition it is full. Small process need to wait to get memory. This small process will need to wait for getting the memory. Here, free memory is available, but it cannot be used for small process. Here, free memory is available, but we can't allocate it to queued process. Okay. Now we'll see single input queue. Using single input queue, how it is work. Only single queue is maintained for all partition. Right here we can see that only single queue will be maintained for the whole partition. Whenever any process comes, it is put in a queue for smallest partition large enough to hold it. Like this, when this process will come, first of all, it will find that which is the smallest partition which is free. Let's say partition 1, if partition 1 is free, then it will, when any process come, it is put in a queue for smallest partition which is large enough to hold. Partition 1 is free and 1 is smallest partition. But this process is larger. It is having large space than this partition size. So we will find another partition, another smallest partition to acquire these, to execute this process, right? Which is large enough for this particular process. When partition becomes free, a process from the front end of the queue is allocated that partition. As soon as any of the other either of one partition will be free, the next first process will be allocated to that partition. Now, what is the disadvantage of this? What is the disadvantage of, sorry, I changed the slide. Okay, process can be selected in two ways. Process that can be selected in two ways. Just select process which is near to front of the queue. Large partition will be wasted for a small partition. It is also similar to the multiple input queue, that it will also find the which one is the near to smallest partition, and then after it will be allocate to that particular process, right? Search entire queue and select largest process which can fit in the partition, right? What here telling that search entire queue, select the largest process. We need to search that which process is the largest process so that we can directly allocate bigger partition to that particular process, right? Now, what is the disadvantage of this fixed partition? That is a starvation process. That is a starvation process. Why? Because for each partition, separate queue is maintained, right? So whenever any process comes, it is put in a queue for smallest partition large enough to hold it. When partitions comes free, when partition become free, a process from front end of the queue is allocated that partition, as we have already discussed in both the process, right? Now disadvantage is if queue for a large partition is empty but for small partition is full, small process need to wait to get the memory, right? Here, free memory is available, but it cannot be used for the small partition, right? Now, advantages of the fixed partition method. It is easy to implement, simple to implement, and processing overhead are low. Disadvantage of fixed partitioning method. Partitions are fixed size, so any process in a partition not used for a process is waste. Any space in a partition which is not used by a process is wasted. This is called internal fragmentation, right? Degree of multiprogramming is fixed here. Maximum number of process can be executed simultaneously, that can't be changed. So here in this video lecture, what we have discussed, first of all, we have discussed about the memory allocation, which is in a different two-way available: continuous memory allocation and non-continuous memory allocation. We have seen that it's different techniques, non-continuous techniques and continuous techniques, right? Then after, you have the brief introduction about the continuous memory allocation, non-contiguous memory allocation. Then we have seen the technique, one of the technique of contiguous memory allocation, that is a single process monitor, right? How it works, how it allocate the memory. Then after we have seen the multi-programming with fixed partition. Again, from that we have learned that using multiple input queue and using single input queue, what will happen? Okay. And at last, we seen the multi-programming with fixed partitions, advantages and disadvantages. Okay. Thank you.